Right, this review is for Math 1314, Test 3 review for our 2-day class, our 2-day Coreq class. So let's go ahead and get started, and I'll just go through them kind of quickly. When you're evaluating functions, remember the function will be provided for you at the top. To find f of 8, you go to function f. Everywhere that they have an x, we're going to plug in an 8. Build it ahead of time. This is going to be 16 minus 3, which will give us an answer of 13. For g of 4, you go to function g. And everywhere that they have an x, we're going to plug in a 4. Use parentheses when plugging in so you don't lose anything. This is 2 times 16 minus 4, which is 32 minus 4, or 28. When you evaluate h at 8, you go to function h, and again, everywhere there's an x, we're going to put in an 8. This one has a numerator and a denominator. We're going to get 64 over 4, which we can reduce to 16. For j of negative 3, now for function j, if you have a hard time figuring out which one to use, graph these inequalities at the end. The top piece we will use for any time we have a number that is 2, because you get a solid circle at 2, or goes to the right. So if it falls in that area, we're going to use the first part of the function. I can graph the second one at 2. We need an open circle. This one goes to the left. So if you have a number that is smaller than 2, but not equal to 2, we're going to evaluate it in the second piece. So for ours, j of negative 3. Negative 3 would fall in this area, wouldn't it, in the second function. So we're going to use the 9x plus 3. But everywhere we have an x, we're going to replace it with negative 3. Now we get negative 27 plus 3, which will give us an answer of negative 24. For j of 6, 6 falls into this top area, doesn't it? So we're going to use 4x minus x squared. And everywhere they had an x, we're going to plug in 6. So we're going to get 24 minus 36, or negative 12, will be the answer there. For h of negative 2, again, h is that fractional looking statement, that rational function. So we'll plug into the top, negative 2 squared. For the bottom, it's x minus 4. That'll be a negative 2 minus 4. And we'll use order of operations to clean it up. That is 4 over negative 6, which reduces to a negative 2/3. Let's keep going. For f plus g of 1, that is the same thing as f of 1 plus g of 1. We're going to evaluate the f of 1, we're going to evaluate the g of 1, and then add them together. We have, first of all, f of 1. Function f is 2, and I'm going to do it like this. I don't have very much room. For f of 1, we're going to plug into 2x minus 3. So for x, we'll put in a 1. For g of 1, we're going to plug into 2 x squared minus x. Again, for each x, we'll plug in a 1. 2 minus 3 is going to give us a negative 1, plus 2 minus 1, which is 1. It's equal to 0. It is okay to have answers of 0. For f of g of negative 2, we bring the first function down. The second function goes in the bracket. So we're going to have f of whatever g of negative 2 is. For g of negative 2, in function g, I will plug in a negative 2 and then clean that up. Negative 2 squared is 4, times 2 is 8. Minus a minus 2 is going to give us plus 2. So now this turns into f of 10. Excuse me. For f of 10, I'm going to plug into 2x minus 3. But everywhere they had an x, we're going to put in a 10. That is 20 minus 3, which is 17. or g times h of 1. That is the same thing as g of 1 times h of 1. So we'll evaluate function g and multiply what we get by h of 1. For g of 1, function g is 2x squared minus x. We'll replace those x's with 1. For h of 1, that is x squared over x minus 4. We're going to clean that up. 2 times 1 squared is 2 minus 1. That whole thing is going to be 1. Over here, the top will be 1, and then 1 minus 4 is negative 3. 1 times negative 1/3 is negative 1/3. And finally, in this video, I want to go ahead and cover our domain. We only have to know the first 3 types of domain that were covered in the class. And the first one said if we have no denominators and no radicals, the domain is automatically all real numbers. If you have a square root, our domain has a condition. So we will write all reals such that. To find the condition, you're going to take whatever is underneath the radical and say that has to be greater than or equal to 0, because we can only take the square root of positive numbers or 0, and then we'll solve. We'll move our 3 over to the other side. We'll divide both sides by 2. My x's have to be numbers greater than or equal to negative 3/2. Now, even though it's not on here, I do want to cover the other domain problem. So I'm going to stick it right in here. You are responsible for all 3 of them, and these 2 happen to be on this practice exam, but they're not the only ones you have to know. If you have a function where you have a rational expression, x of 1 over x minus 1, denominators have one number or 2 numbers that can't happen because they'll make our denominators go to 0. So our domains have exceptions. So we're going to write all reals except. To find the exceptions, we'll set our denominator not equal to 0, which means x cannot equal a positive 1. And I'll see you in the next video.